The next lesson is about perfect cube roots. So we're filling in a table. You should have a handout that goes with this. Or you can make one in your notebook where we'll find all the perfect cubes. What I'd like you to do to fill this in is make a cubes list also. So it'll be a cubes and cube roots list. Multiply the number by itself 3 times. That's how you cube something. And put that number inside the root. And if you take the root, the cube root, then you'll get 1. This works with 0. With 2, you would put 2 cubed, which is 2 times 2 times 2 again. That's 8. This also works with negative numbers. So if I did -1 times itself 3 times, that's -1. And -2 cubed is -8. So there's a table for you to fill in. It's numbers 1 through 10 and -1 through -10. Probably the quickest way to do this is if you put in your calculator y equals x cubed and then looked at the table. That would be the quickest way to do this. Also, make a note for yourself on your TI-84 calculator or 83 calculator. If you use the math button and choose 4, there's a cube root operation already stored in your calculator. So go ahead and fill in your table. Now that your table's done, we'll continue the rest of the notes. For one thing that's important to recognize, how did we cube something? Well, we multiplied by itself 3 times. Also, HK in our transformation equation is always an important part. For a cubic and a cube root graph, it's called the inflection point, and you can abbreviate that IP. You can tell if a graph is cubic if it is an up and down graph. Cubic is actually up and down. Half of the graph opens down and half of it opens up, and that might remind you of a quadratic graph, x squared, which either opens up or opens down. But to differentiate that, a cube root graph is a side-side graph. So cube root opens to the left and to the until the inflection point, and then after the inflection point opens to the right. This is for the original graph. And so this is a sideways graph similar to square root, which was also wider than it was tall. And you read a graph to determine if it's increasing or decreasing by looking left to right, just like you read sentences in English. And it's kind of like slope. If the y's increase as the x's increase, that would be a positive slope. That also shows that your graph is increasing. And if from left to right, as the x's increase, the y's decrease, then you have a decreasing graph. Okay, here is information about the parent graph for cubic. We just made a list of perfect cubes. So we can use that information. That should be helpful. Now, I'll put the inflection point in the middle of my table. This would be HK if we had transformations, but there's no transformation here. HK is 0, 0. So that's where I start plotting. And I'll use a couple of X values that are to the left and a couple of X values that are to the right. And we just made a table of cubes. So you can fill this in, the Y's, by calculating or by using your table or the list that you just made. Or you could put this in the calculator and use a table from your equation and fill in points that will fit on your graph. And we'll go ahead and graph this function. In the middle of this, it looks like there's a line of these points through the middle, and it isn't actually a line. As I explained just a moment ago, half of your graph opens to the bottom, opens down, and half of your graph opens up. So this is actually a curve. It either goes curving up or curving down. The inflection point in the middle is where your curve changes directions. The domain for this graph, because it continues down and left to infinity, negative infinity, and up and right to positive infinity, the domain is negative infinity to infinity, as is the range. And this will be true regardless of transformations, reflections, shape changes, moving the inflection point. You'll still have all real numbers as your domain and your range for all graphs that are cubic. From left to right, this graph is increasing. It's increasing up much more quickly than it increases right, but we're going to say this graph is increasing. Right below this, there's a place to fill in the cube root information and graph. And cube root is inverse of cubic. So from the information you have right here, if you trade X's and Y's for your table and trade domain and range for the cubic or cube root graph, then you can plot your inverse. So that will look like this. Inflection point in the middle. Having a difficulty here. Let me try again. Inflection point in the middle, which would be HK, but there's no transformation here. This is the original graph. And we will do the inverse of the graph we had for cubic. We can also exchange domain and range, which means domain and range for cube root is also negative infinity to infinity, always. Then we can plot your cube root original function. And this one grows left and right much more quickly than it grows up and down. But from left to right, this graph is increasing. So we mark it increasing. There you go, guys.